We are going to calculate the standard deviation for the following set of population data: 15, 12, 6, 14, and 9. First, calculate the population mean. Well, since there aren't very many data items, there's not really any need to do anything more in-depth than just add together the data items we have and divide by the number of values. So that's 5 items. If I add them together and divide by 5, I've got 11.2. So the population mean is 11.2. Next, fill in the table below with the deviation of each data value and the square of the deviation. So the deviation is the distance from a data value to the mean. So it's a measure of linear distance. So we're going to see how far away each of these data items are from the mean itself. So to find a deviation, I just need to take each individual data item, so 15 is the first one, and then subtract the mean, which is 11.2. And that's going to tell me how far away that data item is from the mean. So it is 3.8 units above the mean, and that is positive because it's above the mean. Now, if I square that value, so x minus mu squared, that's what's asked next, that would be 14.44. So we'll go ahead and put that in. I'll explain why we square in just a bit. Now, 12. If I take 12 and I measure its distance from the mean, then I would be taking 12 minus 11.2, which is 0.8. And then if I square that value, I get 0.64. Now, if I take the distance of 6, so 6 minus the mean of 11.2, it's negative 5.2. So what that is telling me is that this value is below the mean because it's a negative distance. So negative 5.2. And if I square that value, I get 27.04. Okay. 14 minus 11.2 is 2.8. And when I square that, 7.84. And lastly, 9 minus 11.2 is negative 2.2. When I square that, it becomes 4.84. Okay, now the reason for this squaring business. Essentially what we're trying to do with the standard deviation is come up with something that is similar to the average distance of each data item from the mean. So we're getting all the distances of each data item from the mean, but there's a problem. If I take all of these data items and I add them together, so taking into account positives and negatives, I end up with 0. And it's nothing to do with this particular data set. It's just a property of how the mean is defined versus how it interacts with the data values. So we can't really get away from that. Every time we do the sum of the deviations of a data set, they'll add up to 0, which means we can't really average them because now we take the sum divided by the number of data items. This would always be 0. So that's not really helpful. Now there's two potential solutions here. One is to take the mean absolute deviation, which means to take the absolute value of each of these and then take the average of those numbers. And that is one very approachable way. And there's reasons that statisticians don't use that in general, but it is a measure of spread. The accepted method is to square all of our values. So I take the square of each of those deviations. that always results in a positive answer, for which I can add all of those values together. So let me do that. Okay, so 54.8 is the total there. Now, to calculate what's known as the variance of the data set, I take the sum of all the squares of my deviations, so that's what is meant by the numerator here. So that's my 54.8. And I divide by the number of values that are in the data set. And there's 5 data items in the data set. So I just take this 58.5, or 54.8, and divide by 5. And that's 10.96. Which, if you look at and compare to each of the deviations, each of those values is much less than 10.96. So this value is really much larger than what it should be. And the problem is squaring each of these numbers. So these numbers are inflated by the act of squaring. So to try and counteract that, when we get the standard deviation of the data set, what we do is we take the square root of our variance. So the square root of 10.96, that in our calculator is 3.31. And I'm just going to take to 2 decimal places, but follow any rounding instructions given in the problem. Now, this is known as a population standard deviation because when we got the variance, we divided by the number of data items that exist in the data set. If we do a sample standard deviation, you actually divide by 1 less than the number of values in the data set. And that's the difference in that calculation. So always make sure you know which one you're supposed to be doing.